In the last video, we talked about the ASA triangle congruence criterion, that if you had two triangles and you knew that two pairs of angles were congruent between the two of them, and the side that was between the two of them was congruent, that was enough information for us to know that the two triangles are congruent. In this video, I want to look at a slightly different problem. What if we've got two pairs of angles that are congruent, but I've got a side which is not between them? So this is called AAS. So the S is not between the two A's. In ASA, the S is between the two A's, so that means the side has to be between the two angles. This is AAS, where the S is not between the two A's, and so the side has to not be between the two angles. Let's see if that makes the situation any different. All right, so here I've got two triangles, and so angle A is congruent to angle X, angle B is congruent to angle Y, and AC is congruent to XZ. Notice in both of these, the side is not between the two angles. We couldn't have a situation where one side, in one triangle, the side was between the two angles, but in the other one, it was not. And let's see if we can convince ourselves that these two triangles have to be congruent. All right, so let's say that, let's let X be the size of angle A. So therefore, angle X has to also have side X, and angle B has measure Y. All right, so since those are congruent, we've got the same X and Y, the same X and Y. So the measure of angle C, to figure out what that is, well, I could add X and Y together and then subtract that from 180 degrees. And that would tell me how big the missing side was in this angle. How about for this one, if I wanted to find the measure of angle Z? Well, I would do exactly the same thing. I would add X and Y, and then I would subtract it from 180 degrees to give me the side of the third angle. So can you see that the measure of angle A and the measure of angle Z are both the same? It's the same formula for both of them. So therefore, I know that angle C must be congruent to angle Z. And therefore, even though I started with two angles and the side that wasn't between them, now I can use the ASA theorem, because here is two angles and the side between them. Here are two angles and the side between them. And so A is congruent to X, C is congruent to Z, this side is congruent to this side. So therefore, these two triangles are congruent. Does that make sense? So let's think about the rules we have at this point in time. So at this point, we've got 4 triangle congruence criteria. We've got SSS, so 3 pairs of sides. I can have 2 pairs of sides and the angle between them. Or I can have 2 pairs of angles and the side between them. Or I can have 2 angles and the side that's not between them. All right, and so the question is, can I, let me put a box around this and put some question marks. Can I have a situation where I have 2 sides and the angle that's not between them? Is this a triangle congruence theorem? So this is a question that we will tackle in the next video. And we will see that that is a triangle congruence theorem that actually does not exist.